Welcome back to this next section of the lesson. Bear with me, this section may be a little bit longer, but I try and keep it a bit brief too. We are talking about domain and range of inverse, expression for F inverse, and versus defining, and of course later on we talk about the graph. First, we talk about domain and range of an inverse function. To illustrate what I mean, I want to use a simple example. Say F, the rule is 2x plus 1, right? And x can just be two different numbers, 0 and 2. Okay, so basically this is the domain like that. All right. So if I were to express this in this set here, what it means is under the function f, the image of f, image of 0 under f, you put 0 in, you will get a 1. And the other element possible is just a 2. The image of 2 under f, if you substitute 2 in, you get a 5. Is this a 1-1 function? Yes, it's a 1-1 function because 1, 1 like that. Only like that. Now, I think it's obvious that the range of the function here is 1 and 5. Now, but the inverse function is this. It goes the other way. I think it goes without saying that 1 and 5 now forms the domain of the F inverse. I repeat again, because this part here, these numbers 1 and 5 is what you use, what is all is now the elements under F inverse, and 0 and 2 are now the images of the elements 1 and 5 under F inverse. Make sense? So I would like to say this domain of F is just 0 and 2. Range of F is just 1 and 5. Similarly, this is actually the domain of F inverse because you're going to put in these two numbers into F inverse. And then these two are the range of F inverse because these two are all your possible images. Now, I'm giving a specific example, but actually this is true for all functions. You may want to review it, pause, rewind this video if you are not clear. Next, I want to distinguish between finding an expression versus defining an inverse function. I want to talk about this example 9. We take a look at example 9. Define the inverse of f in a similar manner. Now, what makes up a definition of f? Sorry, this is an f inverse. I beg your pardon. All right, there's a typo here. Inverse of the function f. Sorry, correct. It's correct. All right, inverse of function f. Basically, this means f inverse. Define f inverse in a similar manner. To define the f inverse in a similar manner, we must first define the rule. Let me very quickly do this. Let y be equals to e 3x minus 2 plus 1, which means e 3x minus 2 equals to y minus 1. 3x minus 2 equals to ln y minus 1. X therefore is equals to 1/3 ln y minus 1 plus 2. Now this is then the rule going the other way. Go and review the last section of the notes. If you're not clear what am I doing, I think it's obvious that now the rule for f inverse x is just 1/3 ln x minus 1 plus 2. Notice the change from y to x here because I'm actually here f inverse x. In order to fully define f inverse in a similar manner, you notice this whole definition here includes also the domain. This is actually the domain of f. So in order to define f inverse, your final answer must look like this. with a domain. And the domain, of course, must be, I beg your pardon, must be of F inverse. Right? Your final answer must be here. But what is actually the domain of F inverse? May I go back here? The domain of F inverse here is actually the range of F. So we must then, find the range of F first before we can complete the solution. I'm just very quickly going to go through the answer, right? If you were to sketch the graph of fx, right, you will realize that this is the graph of fx, like this. Okay, don't ask me how. I want to jump straight into finding the range of f from the graph actually is 1 to infinity. Okay, from the graph of f. Okay, right, from the graph of f, the range of f is from 1 to infinity if you were to sketch this one out. Hence, the domain of f inverse, which is range of f, is 1 to infinity. Which means you write here x belonging to real and x greater than 1. So this forms the complete answer to defining f inverse in a similar manner. The similar to what? Similar to what? How f was defined. Let's look at example 10. Example 10 is phrased slightly differently, even though it's still talking about inverse function. The question only wants you to find g inverse x, which is actually just the rule. They didn't ask you to define. Right? So the rule, again, we have done this before. You let y be equals to, minus 3 minus 4. Make x the subject. At this point, I want to highlight this idea of a plus minus here. Because you have x minus 3 squared equals to 1, y plus 4, you do not assume that it's always a positive square root. Super important. Highlight, put star, put sticker, put anything on your notes. Please write down now. Do not always assume. And in fact, you have your printed notes in front of you. Please go and look at example 10. Do not always assume it is a positive square root. Really, put star, put sticker, put anything. I don't care what. Highlight, write big, big. Highlight that part. Okay? Then when you make x the subject, you will get x equals to plus minus 3, x3 plus minus square root of y plus 4. But you cannot leave your final answer as plus minus. Why? Because eventually your final answer is going to be a rule. And for that rule to define a function, remember every single element must have one and only one image. So if you leave the plus minus here, you got a big problem. Right? If you leave the plus minus here, you got a big problem. So we must then decide whether it's a plus and a minus sooner or later. The answer lies in the domain here. Let's be clear. This x here is this x here. Because we put in values here, right? We say, okay, x more than 2. So 1 under the function f1, you will get 1 minus 3, you get 0. Correct? Your x, you will get your y here. So the x here can only take on smaller and equals to 2. Then when I make x the subject, x here in terms of y, this x is this x. For this x to be smaller or equals to 2, you look here carefully. Should you choose the plus square root or the minus square root? The answer is very obvious. You will say since x is smaller equals to 2, x must be 3 minus. Because if it's a plus, this whole x will be bigger than 3. That is how you decide. And therefore, final answer is 3 minus square root x plus 4. Again, do rewind and play the notes again, play the video again, read the notes carefully before you progress to the next section. Last part before we can stop for this section, 4.6.5, the graph of f and f inverse. Let's look at this. Is it obvious that here, if fa equals to b, right? If fa equals to b, this means that ab is a point on y equals to fx. Correct? Because you sub a, you will get b, ma. Yes? A is the x coordinate, b is the y coordinate. If this is true, actually f inverse b is a. Correct? So if you refer to the graph of f inverse, actually you put b in, you will get the y coordinates a is a point on y equals to f inverse x. Example, very easy. Let us give an example. Correct? Let's say fx is again 2x plus 1. Right? I put 0 in, I get a 1. Correct? I put 2 in, I get a 5. So 0, 1 and 2, 5 are all both points on this graph. 0, 1 and 2, 5 are all on y equals to fx. Does it make sense? Now I put f inverse x. If you find the rule on your own, right, you will get x minus 1 over 2. I leave it to you to do this work. Now, it means that when I sub 1 into here, I'll get 0. I sub 5 into here, I'll get 2. Meaning to say, on y equals to f inverse x, 1, 0, sorry, my 0, 1 should be here. 1, 0, right, and 5, 2 should be the points on f inverse. So, I erase this. You may pause the video if you want to do this, right? There are some markings that I need to show, right? Therefore, it's quite obvious that this is true. And with this relation to be true, if AB is a point on fx, then BA is a point, actually you will realize that an implication of it is these two are reflections of each other in the line. Don't believe, you try. You plot 10 points, you will know. You try and plot 10 points, you will get it. I want to talk about example 11. Why do we want to use this idea? Let's take a look at example 11. Refer to your notes, no problem. I will assume that this one is easily done. Sketch this on the same axis. I will assume it's done. You can sketch this on your own. What I want to find out, I want to go through is this one. All right. Suppose you have done the sketching. They want to determine the exact coordinates of this point, which is where the two curves f and f inverse intersect. Now, recall, f and f inverse intersect in the line y, or rather f and f inverse are reflections of each other in the line y equals x, which is essentially the 45-degree line. To find out the point of intersection here, I am not going to solve fx equals to f inverse x. I don't want to solve this. Not because it's not correct, but rather it's difficult. I repeat, but rather it's difficult. In this entire example, the question actually didn't even ask you to find the expression of F inverse. I repeat, the question didn't even ask you to find the expression of F inverse. They only asked you to sketch a quadratic. Then after that, use the idea of reflection to sketch the inverse. That's it. Right? This is y equals to fx. This is y equals to f inverse x. The question never asks you to find the expression. Now, I just want to find the coordinate of this one. I don't want to solve this. Why? Because there's an easier way. The easier way is this. The intersection between fx and f inverse is actually the same as the intersection between fx and the straight line y equals x. I repeat, these three things, these three curves intersect at the same point. So instead of solving this one, I will solve fx equals to x. It is a lot faster. So let's solve. And I don't think it's difficult to solve. I want to put, you can read on your own, x equals to 3 plus minus square root 21 over 2. Quadratic, I don't want to spend so much time, you get plus minus. But there is only one point here. Is it a plus or a minus? We will look at x greater or equals to 1. If it's a minus, it will not be greater or equals to 1. Therefore, you will say since x greater or equals to 1, x equals to 3 plus square root 21 over 2. Done. So you can refer to your notes for the detailed explanation, but I want to emphasize that this is not wrong, it's just very, very tedious. Alright, that's that for this section. Please again rewind, replay if you need to.